Hello and welcome to Pharma-info. Now today our topic of discussion is methyldopate. So in this discussion we are going to discuss about the IUPAC structure, pharmacology and the synthesis, right, of methyldopate. So now without wasting time, let's just dive into the main discussion, right. So now coming to the structure of methyldopate. So we all know that dopate, that means it's a modified version of dopa. So dopa is found to be the precursor of dopamine. Dopamine is found to be the precursor of noradrenaline. And we all know that all three are having catechol nucleus common in them, right? So let's build the structure of catechol first. So this one is your catechol, right? And we all know that they are nothing but beta aryl alkyl amine. This is found to be the general chemical class in which all this dopa, dopamine, then noradrenaline, adrenaline, okay, all belong to the same, structural class, right? That is beta aryl alkyl amine. So with respect to what beta? Beta seems to be the position with respect to the amino. So beta means, so this is the beta, this is alpha, and we have an amino here, right? So this is found to be the basic skeleton of what? Biogenic amines, okay, or catecholamines. So this is your catecholamines. So dopa means it must have the carboxylic group, because upon decarboxylation only dopa turns to dopamine, right? So that means the carboxylic seems to be common, okay, common, right? And so we are almost done with the, so this is found to be the structure of dopa, right? Now since dopa is having an amino at the same time carboxylic, the maximum propensity or the probability of the dopa is to stay in zwitterion form. So therefore it is very hard to put it in parenteral formulation. So that is why they thought of converting the amine acid into an ester. Thus they can avoid the problem of incorporating it into a parenteral solution. So that is why what they did actually, they just targeted this carboxylic group and just convert this carboxylic group into COC2H5. So this is your dopate, right? So we have an additional methyl. Where to place? It has to be placed at alpha position, alpha carbon, right? So we are almost done with the structure of methyldopate. Now we need to, only thing is the left in the processes, we should fill it up with the hydrogen to satisfy the valency and all. So this is about your the structure of methyldopate, right? So now let's move on to the IUPAC of methyldopate. So how it goes actually, IUPAC naming of methyldopate. So IUPAC naming means, so first and foremost thing is that we need to see that in any of the compound, right? First thing is that we need to search for the parent molecule, right? So here amine is there, all is there, ester is there. So definitely it is the ester that should get the preference, right? So that is why ester seems to be the parent here, and the ester comprises of how many carbon atom? So this is found to be the longest chain, what we can say, right? Since this is found to be the longest chain and it comprises of 1, 2, 3. 3 carbon. 3 carbon means propanoate. So this is basically ethyl propanoate. And since, so ethyl should be placed at the very beginning of this process. So ethyl seems to be the beginner, what we can say, right? So ethyl, and at last we are going to write what? Propanoate, right? So we are almost done with this, right? We are almost done, or we are done with the parent compound. Now we need to see that what are the substituents, and that need to be plugged in, right? That need to be inserted in between this. So now the numbering should start from here, 1, 2 and 3, right? So we have several substituents, okay, scattered all around the ester. So one is at third position, the other two are at second position, right? So first is second position is having amino. As we all know that alphabetically A is coming first, right? So that is why ethyl, immediate next to ethyl we should put the number 2, and then we should write amino, okay? Now we'll come here, we'll shift from here to here, right? So at third position we have 1, 2, 3, 4. So 3, 4 dihydroxyphenyl. So likewise at third position we have 3, 4 dihydroxyphenyl, right? Phenyl, okay? Then what next? We are left with another methyl which is placed at second position. So likewise we should write 2 methyl, and then what is left? That is propanoate. So this is how the IUPAC name stands. So it's ethyl 2 amino. So ethyl 2 amino, 3. At third position, we have 3,4 dihydroxyphenyl, followed by 2. We have another methyl here, so that is by 2 methyl, and finally we have propanoate. So this is how the IUPAC stands. Now, since we have not incorporated any kind of element of stereochemistry, or it has not been presented stereochemically, so that is why we just omitted what? The configurational notation, that is S, right? Why S? Because see, at this location, okay, please let's just try to put our focus here, right? Okay, so this is the area, this is the carbon which is flanked with all 4. 1, 2, 3, 4. All are different, right? So this is found to be the chiral center, and what to observe that it is not the racemic mixture that is found to be pharmacologically acceptable, right? So that means you need to go for a resolution rate, and through that resolution process, they have isolated what? The S form. So that is why S, and before that we should write 2S. Why 2S? Because 1, 2. Second position, which is having a configurational notation, that is S. So that is why 2S, right? So 2S means, S means it is the S configuration that is found to be pharmacologically superior than there are R form. So that is why, so S can be incorporated here, right? So ethyl 2S2 amino you can also write. If you just omit this one, then also we don't have any problem, right? Only thing is that this must be arranged in a proper sequence, or say in a sequential manner, right? So this is all about your IUPAC naming. Now let's move on to the next part, that is the pharmacology, right? So we don't have much thing to say about pharmacology, because we are basically concentrating in this discussion. We are basically concentrating on the chemical aspects of methyldopate, right? So now pharmacology says that it belongs to the pharmacological category of hypertensive disorders. So that is why it can be used as an antihypertensive. It can be used as an antihypertensive, and how it can bring about this antihypertensive effect, right? See, it is basically targeting the alpha-2 receptor, and we all know that alpha-2 receptor is serving as an autoreceptor, and we all know that often they are not resisting, rather they are promoting the alpha-2 activity to relieve from hypertensive stress, right? So that is why it is the alpha-2 receptor, as it is an autoreceptor, it is having a control over the excess release of noradrenaline, and that is found to be the prerequisite. If we can slow down the release of noradrenaline from presynaptic area to the synaptic cleft, right? Therefore, we can, counterbalancing, or therefore we can neutralizing what the hypertensive crisis, right? So that is why methyldopate is such a drug which is basically acting at alpha-2 receptor. It is basically promoting what? The functioning profile of alpha-2 receptor, and just make sure that you must write centrally acting, okay? Because it is basically targeting centrally placed alpha-2 receptor. So thus it is a centrally acting sympathomimetic, not mimetic, rather sympathetic blocker, what we can say. If I say sympathomimetics, that means it can sympathetic. Why sympathetic blocker? Because it's an alpha-2 agonist, but here sympathetic blockers. Why? Because see, it is not at all entertaining noradrenaline to work, okay? Rather, it is resisting the adrenergic functioning but in an indirect way. So that is why what we can say, it's an agonist but yet adrenergic antagonist. Why? Because it is not promoting the functioning profile of adrenergic system. Rather, it is resisting adrenergic functioning by opting a different route, right? So that is why what we can say, it is basically a centrally acting alpha-2 receptor agonist. Right? So this is all about your pharmacology. Now let's deal with Okay. So now let's deal with the synthesis of methyldopate. So methyldopate is having what? Connection like C. We have an ester here, we have a methyl here, and we have an amino here, right? So I'm talking about the alpha carbon, right? Alpha carbon where this ester is there, and then CH3 is there, then amino is there, all are kept here, right? So next to it is a carbon, right? And to that carbon we have an aryl, right? Chalo. So this is how it looks actually. So now, so let's begin the process with a starting material which is having not a catechol nucleus initially, rather That is a methoxylated or methoxylated phenol, what we can say, right? So it is a methoxylated phenol, right? I should not say that this is found to be the methoxylated phenol, right? Now the immediate neighbor of this phenol is found to be a carbonyl, and to that carbonyl, okay, let's do one thing. Let us just, rub this off, and then we'll put here CH2. Then we have a C double bond O, then we have a CH3, right? Okay. So this is how the starting material or the principal starting material looks like, right? This is how the structure stands. So what exactly we draw here, right? So this is a phenol, okay? To be more precise, this is a phenol. Can it be called as an acetone, right? This is an acetone, right? This is an acetone, and it is the acetone. To that acetone, one hydrogen has been substituted with what? Hydroxymethoxyphenyl. So this is nothing but 3-methoxy or 4-hydroxy 3-methoxyphenyl acetone, right? So this is basically an acetone, and to that acetone, one hydroxymethoxyphenyl is there. Right? So this is found to be the starting material, okay? One of the starting materials, right? Now these starting materials need to interact with what? Let's find, okay? What is the second reagent that need to be introduced here? The second reagent, right? So what is the second reagent? The second reagent, so we need to make what? The C double bond O, right? Assume that this methyl is found to be the alpha methyl of methyldopate. So we are already done with what? Methylation, right? No more methyl group need to be added over here, right? Only thing is that the centrally placed carbonyl group need to be modified in such a way so that we can insert what? One amino and an ester, right? So how this can be done actually? So this can be done by introducing what? This can be done by introducing potassium cyanate, KCN, okay, and NH4Cl, that is ammonium chloride, right? So what this two will do actually, they will basically target this carbonyl group, because we know that one of the major reactive area seems to be a carbonyl group, because carbonyl can serve, okay, or rather it has been consistently serving as a reactive area, right? Because we should not touch this, neither this nor that, even not this area, right? Rather this is the area which can be targeted, right? So what will happen when this two, the combination of these two will address or will try to approach this particular compound, right? So what will happen? So initially what will happen once the reaction is on, so what will happen? The centrally placed carbonyl turns to amino, at the same time C triple bond N. Right? C triple bond N. So earlier it was carbonyl, right? When it was carbonyl, there was no chiral center. But once the acetone or the derivatized acetone interacted with KCN and ammonium chloride, what will happen? Reaction took place, and from that reaction, what happened? A chiral center has emerged out. So this is found to be the chiral center. So once there is a formation of a chiral center, you have to, one problem will arise, right? One problem, already arises. That is nothing but it turns to a racemic mixture. It turns to a racemic mixture, right? So we'll go for what? Because we all know that while dealing with the IUPAC naming, what we observe that it is the S form that is found to be pharmacologically more acceptable. So while going for synthesizing of this methyldopate, and that too of the S form, let's do one thing. Once we got the racemic mixture, that racemic mixture need to be resolved so that we can isolate what? The compound of interest, right? That is the S configuration of methyldopate, right? So what need to be done here? Once we got this kind of compound, this is the intermediate, right? That intermediate should appear in the form of racemic mixture. We'll go for resolution, right? So the next step should be the resolution. So it is the resolution, okay? It is the resolution of racemic mixture that eventually give rise to what? Give rise to the formation of S configuration. So assume that this is found to be the S configuration. So after resolution we got what? The S configuration of this resolved structure, right? So what next? Ab kya karna padega humko? Now if your target is to make methyldopate hydrochloride, right? Methyldopate hydrochloride. What need to be done? This C triple bond N need to be hydrolyzed, right? Right? And here we have to convert this C triple bond N into COOC2H5. So definitely we have to take the help of what? Help of an alcohol. An alcohol, and to be more precise, the alcohol is nothing but HOC2H5OH or HOC2H5, right? Chalo. Okay, to be more precise, okay, you should write it like this, H5C2OH, right? Same thing. Chalo, so what will happen? C2H5OH and HCl, what they will do? They will just convert what? The C triple bond N into COOC2H5. Then, since we have introduced HCl as well, because our target has been shifted from methyldopate to methyldopate hydrochloride. So that is why on treatment with ethanol and HCl, it turns to methyldopate hydrochloride, right? So this is how it stands, right? This is how it stands. Now let's do one thing. So now let's do one thing. Let's just in a single picture, okay, right? Okay, we have just incorporated everything in a single picture, right? So let's do one thing. So what exactly we did? We have taken initially an acetone, right? A derivatized acetone. And why am I supposed to call it as a derivatized acetone? Of course, because one hydrogen of this methyl, okay, has been substituted with what? 3-methoxy-4-hydroxyphenyl. So that is why I am just calling it as derivatized acetone, right? So this is basically 3-methoxy-4-hydroxyphenyl acetone, right? Initially, I just targeted this C double bond O, right? And the combination of reagent which I took is ammonium chloride and potassium cyanide, right? Okay. So what exactly I got? I got a cyano or amino kind of stuff, right? Because this carbonyl has been converted to cyano as well as amino, right? So initially we got a racemic mixture, as our compound of interest is S configuration. So that is why at this very level only, or at this very stage only, we are going after resolution. So it is the resolution that fetched us what? The S configuration. The S configuration of what? S configuration of this cyano or nitrile compound. So now this nitrile compound, because this C triple bond N need to be converted to ethyl propanoate. So that is why we have introduced ethanol, and if as our compound of interest is methyldopate hydrochloride, so that is why just in a single step only, okay, we are going to conduct what? Esterification as well as formation of a salt. So that is why this combination has been taken, ethanol and HCl, okay. On treatment of this with this combination, okay, resulted in the formation of what? Methyldopate. So here the cyano, right? Initially it was cyano. The cyano has been converted to COOC2H5. Methyl has been kept intact. Amino, there is no alteration, right? Everything remains same. And earlier, I forgot to tell you, initially it was taken not as a catechol, rather a methoxy. That methoxy got transformed into a hydroxyl. So now with that we got the catechol. To that catechol we have a propanoate chain, right? And to that propanoate at second position we have an amino, we have a methyl, and finally this is the ethyl. And here we got HCl. That means it's the hydrochloride salt of methyldopate. So this is how the entire synthesis stands. So hope you have understood, right? After a span of 4 years, right, we again came back. We hope that we'll continue the session, okay, with you, with all your support. Definitely we can just keep the momentum on, right? So if you if you really want, or if you want me to grow, please leave your comment right in the comment box, right? And please do subscribe my channel, okay? So thank you once again. We'll meet with some other topic in some other day, right? Thank you.